Psychoacoustic measurements methods. So I will go through psychoacoustic measurements methods, hearing thresholds, dB, SPL, dB, HL, dBSL. Some of them. Psychometric function, classical adaptive, constant stimuli, up-down and transformed up-downs methods. Absolute and differential thresholds, signal detection theory, ROC curves, Weber fraction, and power law. So many things. So we have a basic psychophysics. We have a stimulus, we have a listener in a black box, a dedicated psi, the Greek letter psi, and a response f. Goal to is to determine the function psi. Function f is a function of psi, function of stimulus. The response function is a function of the stimulus. We have the absolute threshold, that is the lowest level of stimulus that produce a reaction at the response instrument. Also the lowest level of stimulus that gives a reaction at the response instrument, it's called. It can also be the differential threshold. That is the smallest change in the stimulus delta E that produces a change in the reaction delta F. It's called just noticeable difference. So we have a stimulus, a listener, and a response. We have an active test subject. We have some data, variability, statistics, repetitions, special measuring methods, and we want to reduce number of repetitions, test time, and reduce noise. We have types of test threshold experiments, balance experiments, scaling experiments, and task experiments. The threshold experiments, that is means for instance for the differential threshold, the frequency JND experiment from last lecture. Okay. Second tone is either higher or lower in frequency by some delta F. So it goes up, down, and yeah. So response can be either higher or lower. That is what's called, this is a threshold experiment. Yeah. And of course we know the hearing threshold for normal people, pain threshold, and uncomfortable threshold. We have then a balance experiment. What does that mean? We have some 1 kilohertz tone, and we want to here find out what is the sound in phones. We remember a phone is the same as a 1 kilohertz tone at 40 dBl SPL. A tone with 1 kilohertz with 40 dB SPL also have 40 phones. So, okay. Reference assigned an arbitrary loudness value, for instance 100. Now we are going to scaling experiments. We have an 100 loudness value, listener response with numbers corresponding to the perception of relative loudness. For instance, 50 is half the reference, 200 is a doubled. Yeah. So then we have a task, temporal integration experiments from last lecture. Okay, count the number of steps you can hear in each cage. You have some sound, and it will decrease in level. Then we have a hearing threshold. We have a psychometric function. Normally, we have the level, the classical on-off threshold. That means that we want to find out the fifth. We have some yes response in percent. So low levels, small small response, and at higher level is be goes to 100%. We want to, this classically we want to find out the 50% yes. At which level in dBs, for instance, or SNR is it found? Okay. We can definitions. We have some real experiments from the psychometric function definitions of the threshold, for instance, 50% level or 75% level, or so on. I can just add that if you have a 1 up, 2 down, as a 2 down, that means 1 no and 2 yes, 1 no, 2 yes. That means that that we find out that the probability for a yes is square root of a half is 0.7. Okay, a little bit mathematics. Psychometric functions assumptions often assume a parametric form, a cumulative Gaussian logistic function, often the Gaussian function. Its monotonic percentage yes always increases. Its monotonic increases. Function is time invariant. No change in shape or positions or course of an experiment. And responses are independent of previous experiments. Okay. Methods for measuring thresholds. There are a lot of things here. Classical methods, methods of limits, Becquerel methods, counting methods, method of constant stimuli, adaptive methods, simple up-down, transformed up-down. I can't remember everything. I can't, but I can mention some. Methods of limits. I'm never going to work with this. Okay. Methods of limits. Approach thresholds from both directions. From well above, decrease until no response. You get a yes, and you have a level, high level, and you get a yes, and the level will decrease at a certain amount, and yes, until no. Decrease until no response. From well below, then you get a no, and just below, you start increasing yes. In T-spell you go down in levels, and in the same amount, instead the same amount on off, and then the same amount down, and the same amount on, or decreasing and increasing same level steps. Okay, then go up, then till you get a yes, and then okay, thresholds, and then you got when you get a yes, you got a little up, and go down again. So the threshold is average of the limit values. What point on the curve will this give is asked. So Thorsten Paulsen in 2007, page 13, the level of the stimulus is stepwise decreased until a limit is reached where the test subject can no longer hear the stimulus. Okay. A yes is going to be a no. This is called a decreasing series. An increasing series will begin 2 to 3 steps further down from where the stimulus level is increased stepwise. I don't know. An increasing series will begin 2 to 3 steps further down from where the stimulus level is increased stepwise until the limit is reached where the test subject can hear the signal again. Okay. Okay. By continuing these decreasing and increasing series, a number of limits can be determined. The threshold is then determined as a mean of the limit values of the 50% on the psychometric function. Down, 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 up, 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 up. Vexissimos. I can't. It's something about to keep the you always press a button or something. Yeah, it's another way. It should be called an automatic version of methods of limits. Then you have the scanning message, modified version of limits. You start well above expected threshold. If yes, you get a yes, then decrease level by a large step, for instance 10 dBs each time. Okay, if no, then increase by a smaller step, for instance 5 dBs. Stop criteria is when 3D as counting responses as at same level. So you get 3 at the same level as counting level, and you get a yes, you get down, and yes, 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 no, 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 and yes, okay. And if this last yes is 3 times on the same level, you got response, the answer. Methods of stimuli, constant stimuli, is a pick a range of levels, directly response at each level. Okay, usually presentation sequence is random now. It takes time, yeah, but it should be at the same level. For instance, 6 dBs. How many? Yeah. For instance, 6 dBs. How many? Yeah, so on. 6 dBs, 4 dBs. How many? 2 dBs, and so on. How many? Yeah. Yeah. Adaptive methods. The course of the test is determined by the data obtained during the test. Stimulus level is dependent on the response from the previous presentations. Okay, so it's not independent now. It's adaptive. Time efficient. Focus on a threshold instead of an entire curve. Possible to avoid presentations where the response is almost certain beforehand and is computer controlled typically. You have simple up-down, similar to the methods of limits and Biggsy methods. You need three things before starting: start level, pick a step size, and stop criterion. If yes, then decrease level by one step. If no, then increase by one step, and it should be the same levels steps. You get okay. Example: stop criteria after 8 revolutions. You start. You say start level just above, and then you go from 15, for instance, 5 dBs down, down, down. Yes, 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 and then a no. Then you're increasing. No, 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 until a yes. Okay, up. Yes, 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 yes. No, and up, and then continue. Yeah. Yes. So you got the answer. the end.